Okay. Yeah, let's take a look at this. I think we saw this. I think some people stayed around at the last tutorial to look at this here. So let's look at the question. There we go. So let's take a look at 5b here. So let's see what we have. So we're adding a bunch of vectors. Now here, notice that the vectors are being given as starting at one point and ending at another point. So P, S, R, Q, those represent points, and we've got vectors that are joining those. So if I even just try to draw this, let's say I try to draw this. So say this is point P and this is point S. So there's the vector PS, okay? And then here, let's say I've got vector R here, and then looks like I need vector Q, point Q, so I can draw the vector RQ. There's RQ, but then I've also got the vector RS, so in that direction, and then I've got the vector PQ. So I've got all these vectors, but I see here that I'm adding and I'm subtracting. And when we're adding and subtracting vectors, how would we like these vectors to be placed in order to add them more easily? Okay. Now we always have two ways of doing things, but sort of most of the times, how do we want to place these vectors? There it goes. We want to place them tip to tail. All right. So if I look here, what I'd like to do is I've got, well, PS. I've got this vector here, so that's the first one. Let me start with that one there. But, I've got vector RQ comes next. But what are some of our nice properties of vectors, and in particular vector addition? What is maybe a nice property of vector addition that might come in useful here? Yeah, that's it. Vector addition is commutative. So what I can do, and remember, when I see a subtraction, I could just think of that as adding the opposite. So I think it might be useful to take vector PS and maybe switch these around. Maybe start switching these around and writing this as minus RS, and then plus RQ, and then minus PQ, okay? So this is, I don't know if you see that. So that's all legal. So I essentially just used my commutative property to flip those around. But now, instead of PS and then RS, wouldn't it be nice to have the next vector starting at S? So I got a tip to tail scenario. But what can I do with this second vector? Instead of working with vector RS, what might I do? Anybody give me any ideas what I'm going to do with that vector RS?
You could do plus vector SR.
Exactly.
The opposite of it.
Yeah, very good. Is that use the fact that subtracting a vector, okay, is like adding the opposite. So PS, minus RS is the same as PS plus the opposite of that. Okay, and what is the opposite of RS? It's just SR. So now this becomes PS plus SR. And that's perfect because now I have them tip to tail. So there we go, adding them there. And look what I now have here. I have SR and I'm adding to that RQ already, tip to tail. And now, instead of subtracting PQ, what do you think I might want to do? So maybe we can get somebody else to tell us how we could change this. There you go. Is add the opposite, is add QP. So that now I'm going from tip to tail. And lo and behold, where did I end up after adding all these vectors together? What was the final result? There you go. It just gives me the 0 vector because I ended up exactly where I started. Because remember, when you add a bunch of vectors, the resultant goes from the tail of the first to the tip of the last, but the tail of the first and the tip of the last are in the exact same place. So this here ends up just being equal to the 0 vector. Okay, and so this is where we have to make sure we're careful here that this is the 0 vector, not the number 0. You don't put that arrow there, and it does, certainly wouldn't be a correct answer. Now, the question is, do I really need to go through this process of drawing the diagram all the time? Okay, I would say not really, because when you get a scenario like this, what you want to do is you want to make sure that when you're doing an addition, you always want the first point in your second vector to be the second point from your previous vector. So you get PS to SR to RQ, and then Q back to P. And there you go. There's the 0 vector. Okay. Now, you're not always going to get the 0 vector. If you have, say, PQ plus R, sorry about that. Let's say I had something like this, PQ plus QR plus RS, what would be the resultant of something like this? Can somebody tell me what the resultant of that sum would be equal to? There you go. It would be PS, because these are already set to be tip to tail, because P to Q, so Q is the tip of this vector, and then I'm adding Q is also the tail of the previous vector. So I'm going from P to Q, then I'm adding Q to R, and then I'm adding R to S, and so what's my resultant vector? PS, from the tail of the first to the tip of the last. Okay, so that's sort of the trick to answering these questions, is you want to set it up so that the next vector starts where the last one ended. Okay, does that help for those types of questions? Okay, so I'll assume if I don't hear anything, yeah, okay, if I don't hear anything else, we'll assume we can go. All right, perfect. I feel as though there was another question. Was it? It was the ones, the non-textbook ones, right? So let's take a look at those. Let's find those here. .344, number 23. Okay, well, let's look at that first. We'll look at the textbook ones first. So 344, 344. Number 23. So it was 23. Was that the one we were looking at? I lost the chat there. $344.23. Okay, so let's take a look at 23. Did I give all of these? Okay, was there anyone in particular that we wanted to look at, or do we want to just go through kind of all three, all four, sorry, 5 of them? Okay, E, does anybody want me to do one of the previous ones? Let me know now, otherwise we'll go straight to E. Okay. Sorry, I don't know what that is. Oh, FL, the first one. Oh, A, yeah, perfect. Okay, thanks a lot. Okay, so let's start with A here. So first of all, they want us to write it in terms of these vectors here. Okay, so if I take a look at FL, so I'll see if I can do it without drawing it. So everybody can see my pointer here. So I want to go from F to L. So in other words, it's the diagonal of this rectangular prism. Okay, so, and I can only use these three vectors. So definitely I would take vector A, okay? And then to that, well, one of the things you have to remember about vectors is they're movable. So I'm going to take vector B and I'm going to move it here because the vector Fi is equal to the vector GH. So I'm going to do vector A plus vector B. And then from there, I can move over vector C and put it up there. So it looks like I can just do A plus B plus C, and that's going to give me vector FL. Okay? Does that work? So Phoebe, I think you had asked about that one. Does that make sense?
Yeah, sorry. I was just asking about it because it was similar to 291 number 7 and like the same location of the points, but number 7 just had a negative in it, so I just wanted to see what you did to get that.
Okay. So let's take a look at E now. And I'm just going to take it just so that I can it'll just be a little nicer here. Hold on a second. I'll open up Notebook. And let's see what the, I forgot what the question was. So the question here was IK minus IH. Okay, so let's take a look at IK minus IH. Okay, so so there's I. So we want to, what is it again? It's IK. So IK would be the other diagonal starting from I going to K minus IH. Okay, so I think it would be a good idea is let's actually put these vectors here. And it'll be a little easier, I think, to sort of spot them. So there's IK. And again, you have to remember this is, this is 3D. So, and there you go. And there's vector IH. And this is where I notice that these vectors happen to be placed tail to tail. So what I want us to try to remember is how did we define subtraction when we were looking at vectors that were placed tail to tail? Does anybody remember what represents the difference? There you go. Now, it's not just any diagonal. Which diagonal of the parallelogram? What is it connecting? Because I got to figure if I draw this parallelogram, I've got two diagonals. It's a very special diagonal that gives me the subtraction. Does anybody remember which one?
The tip of H to the tip of K.
There you go. It joins the two tips. But because subtraction is not commutative, we have to be very careful about how we do this. So let me type it out here. So we were looking for, so I'm not going to bother putting vector symbols here just because it's going to take too long. So we have IK. And then minus IH. And who remembers the rule for which tip I start with when I'm doing a subtraction? Okay, so when they're placed tail to tail, it is a vector that joins the tip, but the order matters. Does anybody remember what the rule is?
Is it H to K?
There you go. It's the tip of the second to the tip of the first. Okay, so that's the rule. When you have two vectors placed tail to tail and you're doing a subtraction, it's the vector that joins the tip of the second to the tip of the first. So the vector would look like this. That would be the resultant vector from the tip of the second to the tip of the first. Okay, so step number one was to determine the resultant. So it's equal to the vector. Well, that's HK. And now that we know what this vector is, well, it's a lot easier to determine how to bring in these other vectors. So can you sort of see that I can do vector HG plus vector GK? okay, to get this resultant vector. Well, what is vector hg? Hey, it's just negative b. And what's vector gk? It's just vector c. So I could either write it as negative b plus c, or of course I could write it as c minus b, either one of those. Okay? But what was important here is to first determine what the resultant was, and we just use our knowledge of subtracting vectors placed tail to tail, and then from there we were able to generate an answer based on these three vectors. All right? So it looks like it's negative b plus c. All right, does that answer whoever, I forgot who asked this one? It looks like Jamie. Does that make sense?
Yeah.
All right.
Thank you.
Anything else we want to ask on this question? No? Okay. Quickly review again? Yeah, okay. So the first thing I did is I drew these two vectors. So IK is that diagonal. There's one vector. IH is this vector here. And so, oh, sorry, the first one. Yeah. Okay. So let me get rid of these things for now. Let's get these out of the way. Okay. So the first one was FL. So let's do FL here. There we go. So FL would be this diagonal. Okay, so you got to think it's on the inside. It looks like it's on the outside, but it's on the inside there. And so now let's change our color here. Let's make it, let's see, what haven't we used? Let's use this bright green here. All right. So in order to go from here to there, what I did is I did this vector here, which is the vector A. Then I added to that this vector here, but GH is the same as FI, which is vector B. And then I added this third vector, HL, but HL is the same as vector C. So vector A plus B plus C from the tail of the first to the tip of the last. Okay? Okay, great. Anything else from the textbook that we can think of? No? Okay. So let's go to those extra questions. We can take a look at those. By the way, because looking back, I should have probably taken our second tutorial to be on a Friday, but it was too late by the time I thought of that. So what I might do is I have a lesson with the full course people from 2:30 to 3:30 on Fridays. So what you can do is, if you're interested, where you have any last minute questions for the assignment and you want to just come and ask me a question online instead of getting a video done, I'll invite you at 3:30 if you want to come and ask some questions before the weekend. You can do that. Okay, so let's do those questions. So let's take a look at what the question was. So where is it? Here. So let's write it down. So vector U is equal to 24 north, 20 degrees east. And then vector V is 30 east, 15 degrees south. Okay, just take a quick look, make sure I wrote that down correctly, because I'm going to shut this off. 20 north, 20 degrees east, and 30 east, 15 degrees south. Okay, so let's take a look at this here. Now, when the vectors are given in this format, where the magnitudes are given explicitly and the directions are given explicitly for each vector, I'm almost always going to work tip to tail, okay? In the other types of examples where they just give you the two magnitudes and the angle between them, then it makes sense to start tail to tail, okay? So if I want to add these two vectors, okay, what I always do is I start by making my little cardinal plane wherever the tail of a vector is to help me. Let's see if I can get the lighting a little better here. Okay. Okay. I always put that little cardinal plane to get me set up. So here I've got east 15. Oh, sorry, I'm doing U first. So north 20 degrees east. So north 20 degrees east. Okay. And I'll make my diagram fairly big just so that I've got some room to maneuver. So there's 20 degrees. And then what I do when I want to add the second vector, well, I'm going to be placing my tail to the tip here. So that's why I draw a second cardinal plane. And then from here, I'm going to draw the second vector. So here it's east 15 degrees south. Okay. And I'm going to make this one a little longer since it's 30 and not 24. So 15. And now I can draw my resultant vector. So this is going to be u plus v. Okay. Now, let's put down what we know. We know that this is a magnitude of 24. We know that this is a magnitude of 30. What else do I need here to try to solve this problem? Because as it is, I can't solve this problem. So what's sort of that missing component that I'm going to need to figure out?
You need the angle.
There you go. Yeah, good. I need an angle. Now, which angle do you think I have a good shot at actually determining here? Because I think I'm only seeing one that I can figure out. Which of these three angles, you know, if I call this A, B, C, which of those angles do I have a shot at getting?
A.
So here, if I take a look at this here, my worry is that I know this is a 90-degree angle, okay? So let's see. Do I have enough information? Do you see something here that would be helpful?
Wait, sorry. I just know that the one is 85, but I don't know which. It's across from UV, isn't it?
Exactly. This is the one that I'm going to be able to get, okay? And I need to do a little work. This is where, you know, we got to go back and use a good old grade 9 geometry, and you got to use what we have. And what I have here is I have these two parallel lines, north-south, north-south, okay? And so here I know that if this is 20 degrees, then this acute angle that's also produced by this parallel line is also going to be 20 degrees. Okay. Now, what other angle do I know? Well, hey, I've got a right angle here, and I know that that's 15. So 90 minus 15 is going to be 90, 80, 75. There's 75 degrees. Okay. So now between these two, what do we have? We have an angle of 95 degrees. Okay. So did everybody see how I did that? Okay. Does anybody need me to go over how I got that angle? All right, so I'll just go over it again here. Here I have a right angle triangle, a right angle. Okay. If that's 15, then this portion here is 75. And then here, because I've got two parallel lines that are being cut by this vector, I know that the two acute angles are going to be the same, 20 and 20. So 20 and 75, 95. Okay. And now what am I going to use? Hopefully we're seeing a pattern here. Which of my trig equations is going to be useful for me?
Cosine law.
There you go. And this is where we're going to use cosine law. Okay. So again, you really should be careful here communication-wise. You know, don't put uv is equal to the square root of something. Sorry, u plus v. It's got to be the magnitude of u plus v. You know, it's sort of a half mark lost if you're not using the magnitude symbol when needed. So here, what do we have? We'll just have 24 squared plus 30 squared minus 2 times 24 times 30 times cos of the angle opposite to u plus v, which is 95 degrees. Okay, so let's calculate that. See if you can calculate it before I get to it. If you haven't done it yet, 24 squared plus 30 squared minus 2 times 24 times 30 times cos of 95. Oh, I think I must have forgotten the exponent, the square root. So there we go. That makes a little more sense. Okay. So I'll go to 1 decimal place. So that'll just be an even 40. Okay. All right. Now I need to determine an angle. And again, what's nice about the tip to tail method is that this resultant vector is already placed on a Cartesian, not a Cartesian, sorry, on a cardinal plane. Okay. So it'd be really good to either get this angle here, or I could also get that angle there. So go east that many degrees north, or north that many degrees east. Either way is fine. Some people are picky about using an angle less than 45. I'm not. I don't care. Okay, but either way, what I definitely want to look for is this angle inside the triangle. Okay, and what am I going to use to do this? Who's going to tell me what I am going to choose to use?
Cosine law?
Yeah, exactly. Okay, because remember that when you're using sine law with one angle and two side lengths, there's a possibility, okay, and there's a whole series of possible scenarios where you might have to, there's a scenario where you might have two answers, where you might have no answer, where you might have exactly one answer. I just, why even think about that if I have an alternative, okay? So you might even think about whether, ambiguous case is even an issue here. It doesn't matter. I'm just going to go and use cosine law. Okay, so here my theta is cos inverse of. So if I'm looking for this angle, I'm going to start with that opposite side. So 30 squared, then subtract the other two sides squared. Then divided by -2 times those other two sides. And especially when you get adept at using cosine law, it's not even really that much longer. Okay, but it just means I don't even have to think about any ambiguous cases. There's 30 squared minus 24 squared minus 40 squared divided by -2 times 24 times 40. Okay, and what do we get here? We get, looks like 48.3 degrees. Okay. So now from here, how you write your answer, if I decide to go, north and this many degrees towards the east, well, I'd be adding 20. So here I could give my answer as u plus v is 40. Then it'll be north, looks like 68.3 degrees east. Okay, or I could write my answer as east. So what would that be? That looks like it would be 21.7 east, 21.7 degrees north. Okay, and for those of you who've taken physics, often in physics they use little square brackets there to cordon off the direction. That's perfectly reasonable. If you've been doing that before, you can go ahead and keep doing that. Okay. So how does that look? So now maybe for the second one, I won't do it completely. I'll just set up the diagram. But in the end, it's going to be a fairly similar scenario. What's the only thing that's going to be different when I do the subtraction? What's the only thing that's going to change here when I do the subtraction? Any takers? Yeah, so what's going to change? Notice I drew u exactly as it was. What is it that's going to change? Exactly. So which, no, I'm going to still do it. I certainly could set it up tail to tail, but I'm still going to do it tip to tail. But if I want to do u minus v, what am I going to have to do if I want to use a tip to tail method here? How am I going to have to reconsider this subtraction? I need to consider it in a different way. There you go. I'm just going to do it as u plus -v. Okay. And so there, the direction is going to change. So instead of adding 30 east, 15 degrees south, I'm going to be adding 30, and you just have to swap these two, which is going to be west, 15 degrees north. So that when I draw my second vector, it's going to be west 15 degrees north. Okay, and there's my resultant vector. Okay, and hopefully you can see that you'll be able to determine an angle inside this triangle. And again, what's nice is that your resultant vector starts at that cardinal plane that you've already drawn for the first vector. Okay, is everybody okay with how I got to this? Does this make sense, or does anybody want me to just show that?
Sorry, I just have a quick question about
Yep.
drawing your diagram.
Yep.
Just when I drew it, I don't know, like I drew it all on one. I just drew one like big cardinal plane, and then like the first one, this is just like for the first one I did, like 20 degrees to the north, and then I drew the first small vector, and then like 15 degrees like south of east, and I drew the second vector. But I got the same like 40 as the length, but I didn't get the same angle. So I was wondering if that's just like fully wrong way to draw it, or was it just like a mistake I made?
Is this for the first one? So are you talking about the addition?
Yeah.
So is it that you drew both? Here, let me do this here. So you drew big cardinal plane. So you drew 24 north, 20 degrees east. Okay, so you have that.
Yeah.
And then you drew the other one from the same.
Yes.
Okay, so that would be 30 east, 15 degrees south.
Yeah, and then I did like the thing where you connect, like where.
Yeah, so what you'd have to do is you'd have to form the parallelogram here.
Yeah.
And you did that.
Yep.
Okay, so it should give you the same answer. I guess the question is what angle did you use? Because you've got 20 here, and you've got this one's 15. So that means that the angle between the two vectors would be, well, 90 minus 20, 70 plus 15 is 85. Okay. But is this the angle you use to calculate your answer?
No, I used the 95, like the one like in the.
Yeah, because here, there you go. You would have used the 95 here. And then
Yeah.
what angle did you find? I'm assuming you found that angle there.
Yes.
And what did you get for that angle?
I got 37.
So 37 minus 15 is equal to 22.
Oh, okay.
Which is very close to that angle there.
Okay.
There you go.
Okay.
Yeah, so you got the right answer. Sounds like you did it right.
Okay. If that, so I can draw. It's okay. It doesn't matter which way you draw it then.
Yeah, for sure. For sure. Because remember, there are two equivalent ways at looking at addition and subtraction. One lives within that parallelogram, and the other one is placing the vectors tip to tail.
Okay, thank you.
Okay. Great. Any other questions on these here? So again, this one here, I'll leave it for you folks to finish off. The answer has been posted, so you can check your answer. And remember, sometimes if your angles do look a little different, make sure you're just checking that I didn't write it starting with a different direction. That, you know, if I gave the answer starting at north and you give the answer starting at east, you know, as long as those two angles add up to 90, then you're good.